This is Non-Renewable Energy, Chapter 15 out of the Miller book. And this is where you need to get out your chart to make sure that you are filling in the chart as we go. You'll start that in a couple of slides. So, core case study. How long will supplies of conventional oil last? Well, oil is super important because it is one of our major oil suppliers, or energy suppliers. We use this pretty much for growing food, transporting people, and transporting goods, and then actually making quite a bit of things that we use today. How much is left is really unknown because the United Nations thinks that the OPEC countries aren't exactly telling us how much is left, because if they do tell us how much is left, then we might be more apt to actually start really digging deep to try to find some alternatives. Or we could probably start to waste less. When will we run out? It is uncertain because we don't know exactly our reserve, and it depends on if we continue to use the oil at a rate that we use it today. We use about 2.8% of the oil, and some of the geologists project that we will get down to, we'll lose 80%, so be down left to 20% sometime between 2050 and 2100, depending, like I said, if we stay with the 2.8% consumption per year consumption rate. The three options for us, of course, are to look for more oil, to reduce oil use and waste, then use other energy sources. So for this chapter, we'll actually be talking quite a bit about the non-renewable energy. In the next chapter, we'll talk about renewable energy sources. And you need to actually be the one to think about what energy source is best, weigh out the pros and cons, because none of them are going to be an easy solution. There's not an easy end-all be-all. You have to decide the pros and weigh them out to the cons. Some are going to be cleaner, some are going to be more energy efficient. There are advantages and disadvantages. Some are going to release more carbon dioxide than others, yet it's going to take a lot less energy to extract them. So that's something that y'all are just going to have to think about. This is the Thunder Horse offshore floating oil production platform in the Gulf of Mexico, and you'll see that there are actually going to be a lot of your oil refineries, etc., going to be in the oceans because of the way that the fossil fuels are created and made. It happens quicker when you are over water because of the disintegration process. And remember that we had plate tectonics. Therefore, some places where you'll find these fossil fuels may have been underwater at some point. They may not be anymore, but they were at some point because of plate tectonics. When the other thing you have to think about too with the United States, you know that we found a nice reserve in the Gulf of Mexico in 2006. But with our climate change and the conditions, the storms lately, the hurricanes have been out of control. So that's been problematic for a lot of our oil rigs and refineries that are in the Gulf of Mexico. So natural capital, some important non-renewable energy sources. You can see here your oil and natural gas. Usually they are found somewhat together. Most of your non-renewable energy, basically they're removed from the Earth's surface, from the Earth's crust, and it's going to be coal, oil, natural gas, and some forms of geothermal energy. Your geothermal energy, basically what happens here is that the hot rock and magma is actually creating enough heat to produce electricity. And remember, electricity simply is a secondary form of energy. Your primary source is where you get it from, where you dig it out of the ground. Your secondary source of energy would be your electricity, because then we turn around and use that for energy. But to get the electricity, we're simply trying to have electromagnetic induction to turn a turbine. So if we can get it from burning fossil fuels, basically the heat will help us get the electricity to turn the turbine, then give us the electromagnetic induction, or the geothermal can do that. Geothermal is actually the only energy source that is not indirectly or directly from the sun. It's coming from the core, from the heat within our Earth's crust. And then we have over here, I see our contour strip mining over here. Remember, contour strip mining is simply your strip mining, but you're doing it within the contours of the land. You're following the mountain formations, whereas over here, your strip mining is going to be more perpendicular. And over here we find your natural gas. Usually it is found near oil, and they used to siphon that off as waste, but now they've found out how you can actually use it for energy too. Commercial energy use by source for the world and the United States. You'll see that the United States actually uses a lot less biomass than the whole world does as a whole, because we aren't burning down forests, etc., for biomass. We do use a lot more oil, we use just a little bit more coal, and we do use more natural gas. Overall, we end up using more non-renewable resources, though, as compared to the rest of the world. And your different your different nations will have different, they use different energy differently than we do. For example, Iceland, they're known for their geothermal energy. France, they're known for their nuclear power. So it just depends on the area and what nature has provided, what they are going to use most. Muscle power. Okay, so a brief history on the human energy use. Well, before we had really nothing, before major discoveries were made anyway, we only used our muscles, and they only caught and ate what they could with their own hands. And then they discovered fire. We were actually able to cook food, and then they were able to use fire. They would burn off different plots of land and try to use stampedes to let their animals like fall over a cliff. And then there was modern agriculture where they started domesticating animals to help them so that they could actually plow the fields more and settle down more. Then they started using wind and flowing water. They used wind to help, they used wind to help propel the sailboats, and flowing water to send things downstream and to send boats downstream, etc. Then they started using machines powered by wood and then coal. So they were burning the wood, burning the coal. Then they had an internal combustion engine was discovered by Mr. Benz in the late 1800s. And then we had nuclear energy discovered, where basically uranium pellets they would go through nuclear fission, not fusion, it takes me a second, nuclear fission, and the process of that radioactive atom splitting would release energy. And of course, now we face an energy crisis because of all the air pollution, the water pollution, the greenhouse gas emissions, and basically our excessive use of fossil fuels and not reducing waste. If we can just simply reduce waste, a lot of our problems would be solved. So oil. What is oil? Oil is a liquid fossil fuel formed from the remains of animals and plants that lived millions of years ago. So basically your fossil fuels all come from the Earth's crust, and they come from the remains of animals and plants. And this forms hydrocarbons because of immense heat and pressure over millions of years, so before the dinosaurs. Over millions of years, the remains were covered by layers of sand and silt, and then heat and pressure from these layers helped the remains turn into what we call crude oil. The word petroleum means rock oil or oil from the earth. So petroleum is actually what is found underground, and once you pull that out of the ground, then we call it crude oil. So how was it formed? Basically, petroleum and natural gas, because remember natural gas is found usually where petroleum is, well, it's formed from the remains of ocean-dwelling phytoplankton, and it's usually died probably around 50 million to 150 million years ago. And deposits of the phytoplankton are basically, they end up being near porous sedimentary rocks, near sandstones, and then they're capped by non-porous rocks. And basically the petroleum kind of fills in the pores. And then you have all that heat and pressure, and petroleum is actually less dense than the rock. So over time it's going to kind of migrate upward, and it's going to be trapped in there. And that's why what you basically will do is to extract it, you will drill a well, and it ends up being kind of like an artisan well. So you drill the well, and because of gravity, the oil will go to the surface, will go up because of gravity, and then you use the pump to get it all the way to the surface and for your actual use. Then you have to take that petroleum, which is now called crude oil at this point, and you have to transport it by pipeline, or you can use like a super tanker, or if it's underwater, you can go to a petroleum refinery. And the petroleum contains the natural gas I was telling you about. And usually that gas, it's got a different density, so it's going to separate out naturally. And that's why there's usually a burning flame in photographs of oil wells when you're actually pulling it out for the first time. So it's processed by taking it. First you have to transport it, then you have to refine it, and then it's separated out by boiling point. So usually what happens, okay, if you have your heated crude oil over here, the lowest boiling point, so if you don't barely turn on the furnace at all, and the first thing that's going to come out is going to be your gases. And the second thing, if you turn up the heat a little bit more, your gasoline will boil off, and then you'll have your aviation fuel. And so basically this is lowest boiling point will come off first, and then your highest boiling point down here. So the thicker it is, like your asphalt, that is going to be your highest boiling point down here. Okay, proved reserves at the end of 2007. So you can see where the Middle East where they fall with the reserves. So they kind of have a little bit of a, they have a lot of power over what we can purchase and what the price is going to be. And it's been kind of upsetting because 1/4 of the world's conventional oil is actually controlled by states that sponsor or condone terrorism. So they say the highest priority in fighting terrorism must be to sharply reduce our dependence on foreign oil. Where's the oil? So it's 13 countries, and these are the 13 countries that are part of OPEC. 13 countries have at least 60% of the world's crude oil reserves, and Saudi Arabia's got 25%, and Canada's got 15%. But the thing about Canada's 15% is that it's mostly found in tar sands, and that has not been found to be the most energy efficient of the oil because it's got a lot of toxin and contaminants in it as well, and it's very toxic to extract the oil from the tar. And to actually get to this oil, they have to do a lot of strip mining. And to do the strip mining in this particular part of Alberta, Canada, there's going to be a lot of boreal forest clear cut. And then the wetlands are drained and the rivers and streams are diverted. So it's actually really bad for the environment up there as well. And then actually, in order for this whole process to happen, apparently they need a lot of natural gas. And so when I was saying it's not energy efficient, they're having to bring in natural gas because they don't have a large source of that there. So it's starting to become even not cost effective. But the 13 countries for OPEC, by the way, stands for Organization of Petroleum Exporting Countries, and the members of that are Algeria, Angola, Indonesia, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, Saudi Arabia, the United Arab Emirates, and then also you have Venezuela. So I'll point that out, that not all the countries are actually found in the Middle East. So just keep that in mind. Venezuela is one as well. This is proven versus recoverable and unconventional world oil reserves. And again, you can see the Middle East is highest in that category. How long will the oil last? Well, there's a lot of argument over this. Well, most analysts say it's somewhere between 40 and 90 years at the current rate of use. Remember, we use about 2.8% per year. This National Geographic article says, could this be the end of cheap oil? If so, then we perhaps might have some crash programs to reduce energy waste, maybe, and to shift to non-carbon energy resource like wind or alternatives, which are wind, solar, geothermal, biomass, hydrogen. Those are all just options that we're going to talk more about in the next chapter. But there are concerns if the oil does go, then we will have prices of food that are used by the industrialized agriculture system will actually go up. So maybe people will shift more to local agriculture because the cost of transporting it and even the plastics and pesticides and asphalt that are used and materials in these petrochemical industry are all going to go up. So that's something that's going to force people to change that. Food production will become more localized. Airfare, especially think about the jet fuel, airfare is going to go up, so therefore air travel might decline. And then your automobile industry. So people might actually be switching to less of the SUV reign that we've had. They call it the small truck category. But that's been something the United States has had a hard time letting go of. We're actually probably one of the slowest in switching our energy demand. We usually actually take these small trucks, get somewhere usually less than 20 miles per gallon. Whereas there are some cars, the small cars and some of the alternative cars like the hybrids with the full electric, hybrids, and then the one that uses the brake. They take the energy from your brake to try to use that to reroute energy in your vehicles. Anyway, those are all going to end up being like 50 miles per gallon. So we're probably going to start thinking about different ways to use our vehicles, and we are going to probably re-enhance our public transportation system because we have been very behind on our public transportation system as well. So anyway, the trade-offs. Let's see. Advantages of conventional oil. We should have an ample supply. Yes, we just switched it to 42 to 93 years. It's a relatively low cost at the moment. High net energy yield. Easily transported within and between countries. Low land use. Technology is well developed. Efficient distribution system. The disadvantages are we need to find substitutes quick, sooner than later. They get large government subsidies. Therefore, we're not paying the full market price. So again, if the prices went up, we would probably start looking for alternatives a lot faster. We would probably not be driving that Hummer right now if the true cost of petroleum was explicit. Environmental costs not included in market price. That's what I was saying about subsidies too. Artificially low price encourages waste and discourages search for alternatives. Pollutes air when produced and burned. Releases carbon dioxide because fossil fuels are made of hydrocarbons when burned, and can cause water pollution. All right, this is a bird covered with oil from an oil spill in the Brazilian waters. So unless the volunteers actually remove this oil, it will take away the bird's natural buoyancy and heat in solution, and then it's going to die or drown from exposure because of loss of body heat. And then there's actually some studies that have been done, and we actually have a lab that will display and demonstrate this phenomena, is once you even clean these birds and you take away their natural oil, so even if you use the Dawn or Dove, Dawn, whichever one is that has the cute little animal on the side of it, they use that and say, hey, this is how you can clean up these animals when this happens. But unfortunately, you strip that natural oil so that they're still not going to, their feathers are never the same again. They're not going to ever fluff out the way they used to. So it still impacts them and their buoyancy and their ability to, stoop down and grab the fish at the top of the water, because all of a sudden they're used to flying and getting back up again, and then they just get stuck in the water and they drown. They're heavy. Anyway. Natural gas. Natural gas. The main ingredient in natural gas is methane gas. Natural gas is typically found with oil as they are formed in the same manner. Remember I said that the oil, the petroleum is denser, so the natural gas is usually on top of the petroleum, and it has a natural separation process. So natural gas, let's see here, how it's formed. Same way. So it's formed because of the phytoplankton and plankton that's in the sea floor. It's buried and the water's doing the great dissolving, and then the layers of sand and silt are covering it, and over millions of years the remains are getting deeper and deeper and more pressure and more pressure. And now today we can drill through the layers of sand, silt, rock to reach the rock formations that contain oil and gas deposits. Okay, how is natural gas extracted? It's basically like you're tapping a well, but it's a little different than oil. Miss Settles loves seahorses. This is going to conclude part 1. Ran out of time, but I will post part 2 tomorrow.